Welcome to the Chris Rod Max Show. I'm here today with Chris and Rod, which every week we talk a little bit about AI stories so that you could learn from the experts, not us, but the people out there that are doing a lot of cool stuff with AI. And the whole idea here is basically us breaking out the news, and we hope you enjoyed this week's episode where we talk a little bit about Eric Schmidt, the former CEO of Google's view on AI revolution. Today, we're joined with Rod, Chris, to talk a little bit about Clip. It's slightly different from previous episodes, and the whole idea here is that to find out new ways and to find you the new news. So, how are you feeling, Chris, Rod? Are we ready?
Very excited. Let's do it.
Let's go.
Cool. For those who haven't seen it yet, I think there was a controversial video, it was labeled controversial, about Eric Schmidt, the former Google CEO, talking about AI revolution. And with that, we managed to, secure some videos or some clips online, which we are going to discuss today, so that we could talk a little bit about what is going on.
What's the context? So where was he? What was the point of this interview? What's the story behind?
The story behind is basically Eric Schmidt was giving a talk in Stanford, I believe, and he was basically talking a little bit about the latest AI evolution or AI development with, I would say, all the different Stanford University students. But something that he said around Google's approach to winning was initially known as controversial. He basically said something along the line that, some Google employees decided that work-life balance was more important than winning. I think Rod, Chris, both of you have seen the video before. Perhaps some of your thoughts on why this was controversial as well would be helpful.
So why I think that is controversial was just that so we're seeing a little bit of divide between those who on one side think now is the time to, for example, be fully focused on building things. We have this AI revolution and so on. So we have to really put all our energy into that, pour all our efforts. And then there is another side where it's saying, hey, actually, life is more than just work. There's more things behind and so on. And also on top, thanks to AI, we are having some automation, we're becoming more efficient, and this need of being, let's say, like 12 hours per day at work is becoming less and less relevant. The opposite, thanks to things like AI, it will be possible that we can, for example, just do a few hours a day and still get the same out. So I would say this is just a reflection of a cultural clash that is happening not only in Silicon Valley, but in many other places on what the future of work, and in the end, what is it that we're supposed to be doing? So should we be living for working or working for living?
I think the topic around remote work is controversial, or not even controversial. I think it's just sensitive because we live in a time post-COVID, and I think a lot of employers are really trying to bring people back into the office. I think there's a spark and maybe even a revolution nowadays on the employee side of wanting to have more life quality, and life quality also meaning more flexibility around where to work. And at the same time, I think it has not much to do with the topic at hand, which is AI and its advancement. And I think for that, and I'm sure we're going to deep dive into that a little bit further today, I think it's quite interesting what the former Google CEO is actually saying about the future.
Great. And with that, without further ado, let's start with the first clip of what the Google AI CEO said.
Where do you see AI going in the short term, which I think you defined as the next year or two?
Things have changed so fast. I feel like every 6 months I need to sort of give a new speech on what's going to happen. Can anybody here, a bunch of computer scientists in here, can anybody explain what a million token context window is for the rest of the class?
So the first question, I guess, for the first video of what we're seeing here is basically Eric Schmidt saying about AI development that happens every 6 months. And I just wanted to get a little bit of your thoughts around Chris and Rod. We've been covering this for about roughly 6 months. It does feel like a lot of new things are coming out every day. But without going too much on that side, I'd just love to understand, from Rod, from your perspective, technically, what are some of the big things that are happening? So in this video, he actually talked about token, context, and window, and love for you to, get us up to speed. Some of the latest, I would say, development for the past 6 months, especially technically.
Let's take a step back and try to understand why is he asking this question. So why does he think that speaking about a 1 million context length window is so relevant? First, what is that? It is when we're writing something, for example, to ChatGPT, this is this context window. So it's how much input we are passing in terms of information, background, and so on. And for those who remember how it was very early on, who started using it in the beginning, it was very limited. You could pass, let's say, like a couple paragraphs and immediately you will hit a limit. And as a result, you could not provide too much background information about your problem, about your question. You had to rely pretty much on ChatGPT using the historic knowledge that was used to train it in order to try to understand what was being asked. And now when he's talking about 1 million token context window, it means that we can put these 1 million tokens. This means we can put really like books, entire books as part of our input, and then use this for ChatGPT to, or any other so large language model to execute our so what we're asking. So this means that we can provide one, a lot of new information, two, a lot of information that was not available for ChatGPT. We can think about like company data, about personal information that is not known to the wider world and so on. So this provides so much more nuance and also allows to provide the freshest information. For example, like a breaking news, likely it will not be trained on this information. Something happened 5 minutes ago, but by having these very long context windows, we can introduce these such that the system has an understanding of it.
That's interesting. So that's on one side on the technical bit, which is really putting the entire book into models and making it into, I guess, larger models understand stuff a little bit better. And then Chris, from your perspective, then when it comes to the application development of AI for the past 6 months, we'd love to also understand from your view, what are your thoughts? Is it refreshing every 6 months because of the technical updates that we're seeing? Other than we talk a little bit about, previous episodes, ChatGPT, how it has changed, when they first came out, and love to understand, has it changed as much in the development in every 6 months?
Honestly speaking, I think the biggest bang was November 22 when ChatGPT came out to the public market. I think ever since, yes, there have been optimizations and incremental changes and improvement. Yes, we also see improved models of other competitors that are battling each other on, different fronts and optimization key values. But honestly speaking, I think when was the last time that ChatGPT 4.0 came out? I'm still waiting for the very amazing voice feature that they've actually demonstrated. I wonder if the question is really relevant, whether it's every 6 months or not. I think what's really now, I think, become a bit more in the spotlight is the use cases as well as like the commercialization potential. And I mean, as we've discussed last week, we very interested in understanding, okay, how can actually Gen AI provide value to different corporates and companies? Because this is really the key of whether or not AI will be supported also by the wider, let's say, industry as well as like companies to be developed further. So my point being, it's not necessarily interesting to know whether or not every 6 months there's something new coming out. I think the change is actually gradually and incrementally. But I think the question for me is really the rate of support that the topic actually has. And I think if we look into the stock market, they are actually quite volatile these days. When it comes to like stocks in the AI space, just simply because I think there's a bit of a controversial discussion around the real value of AI. And, you see on one hand, some people arguing that we have reached the peak or the deflation moment in the hype cycle, but then also there are other ones that actually strongly believe that it's still growing and still continuing and that we're just at the beginning.
One thing I was thinking about that, Chris, is that on one side, so this shows how hard it is to really assess which things on what will have impact, and also what becomes meaningful in that. So you were, for example, expecting this so flashy functionality with the voice and so on that's very human. We're still waiting for that. And then turns out that something that is hard to explain, such as this 1 million context input and so on, for a large language model to have as a capability, is in the end what is having a higher impact, is enabling this type of enterprise cases and so on. So it shows how, in the end, it's also very difficult for companies to understand in advance what is it that it will be having meaningful impact and also what they should be investing on.
Adding to this, Rod, I think even the simplest office tasks, I don't think have been solved fully or in a way that people understand how to use it today. Think about a very easy Excel operations. I mean, so many companies still rely on Excel, and you would argue that, with so many more data points that you have at hand, there must be a simpler way to use Gen AI and run through it. But actually, we see that the integration into existing workflows is actually one of the biggest hindering factors of why a lot of companies have not been able to unlock the real value of AI or the potential that it holds.
Just picking up a couple of things that you talk about. So number one, you talk a little bit about, the interests of all the different capital that's flowing into the system. Number two, we talk a little bit about, which is the some of the limit on the technical translation into tangible benefits immediately, at least for now. But over time, that will really happen. And just to pick up on your point on the first one, which is the amount of capital going in. We all know NVIDIA is a big company that worth about 2 trillion. Obviously, they have a huge sellout yesterday, but that is just a daily thing. But one thing that Eric Schmidt talked about in the video is how CUDA works. So I just want to play a little bit on the clip and then really just get both your thoughts around that as well.
There's another insight. There's a set of open source libraries which are highly optimized to CUDA and not anything else. And everybody who builds all these stacks, right, this is completely missed in any of the discussions, right? It's technically called VLLM, a whole bunch of libraries like that. Highly optimized CUDA, very hard to replicate that if you're a competitor.
Obviously, Eric talked a little bit about CUDA, CUDA, which is he dubbed it C programming language for GPU. And I personally would love to understand what is CUDA. So Rod, if you could share a little bit of your thoughts here, what is CUDA? Why do you say the open source part of VLM is very hard to replicate?
In fact, he's not that correct. So where he's saying that nobody's talking about that, we have spoken about it on the show, where we're saying that we have been seeing that other companies are trying to compete with NVIDIA in terms of new hardware, new GPUs, and so on, like AMD, GraphCore, Grok, etc. Right? So we have been seeing new entrants and all other established players who are now offering AI-related technologies like Intel. And we're wondering, why is it that they're not achieving this penetration? And the main insight is that it's not only about the hardware, but it's also the ecosystem that you need in order to build things on top of that. And CUDA is a software library developed by NVIDIA that allows developers to interact on a very low level, so pretty much like doing basic operations with these GPUs that in the end is doing algebraic operations, like some multiplication and so on in a very fast and efficient manner. And by now, this is the industry standard. So pretty much anyone who wants to establish a new technology needs first to capture this developer mind, so the community building these tools. And for that, they need to have very good software, and this software needs to be adopted, which becomes like a true moat for enterprises, because now it is very, very hard for others to try to do things on top. So I've been seeing, so like Intel has some alternatives, of course AMD is trying to do something in space, etc. But this is something that takes so many years, if not decades. So CUDA has been in this space now since pretty much there are like GPUs, has been around for quite a while. And even if others come up with something that is on the same level or maybe slightly better, is the question always for developers. Why should I adopt it if I'm already so invested in this existing stack?
I think for me, it's about the mode that they're building with all these different developers. I think I'd love to understand from you, Chris, from an adoption perspective, how do you see, I guess, the development of all these languages as well as the depth of a development community? And we always talk a little bit about, I guess, the ability to translate some of the technical capabilities to use cases, I would say tangible benefits. And here it's more on the technical side. I wonder if it matters, especially when a large corporate trying to adopt some of these different AI solutions, if you will, for their own.
It's hard for me to comment on it, but as an example, I think whenever you have a new language, it's very, very difficult just from a cybersecurity point of view to get it in, but then also to find the right people within the company to build on top of it. I remember very vaguely, there was this like meme around, I think even Deutsche Bahn or something, where they were looking for someone, a new programmer, actually. It was a job description for an MS-DOS programmer that they needed, because some of the systems are still running on it. And I think, looking into also maybe the aviation industry, at times you still have systems that are from the 70s or 80s, and it's just from a regulation point of view still the mostly widely used and adopted system. And so what I'm trying to illustrate here is that with every new language you bring out into the market, you actually face adoption risk also. I mean, just even something trivial like Ruby, that's, I think, very, very common nowadays in the startup world, is something that is very difficult actually for a lot of companies to adopt to. And so more and more you see that gap of innovation, even where a lot of corporates or companies or larger entities are living in a different system world. And then you have the more agile, maybe the smaller ones and the startups running on a very different world.
I'll be very curious if you could navigate us through where you have in that innovation units, and I assume that very often what happens is that so the innovation unit comes with proposals for new technologies, new systems, new models, something that is innovative, and then is looking for a rollout across the broader organization. What is the decision-making process behind? How is it decided? Should we adopt this? Should we not use it, and so on? How do large companies do that?
I don't think there's a silver lining here. I think these innovation entities, they normally serve to bridge somehow. But again, when we talk about a serious enterprise-wide rollout, that is, A, takes forever to approve, and second, forever to implement, because simply, again, the system is always very, very old. You talk about, you asked about like stakeholders and decision makers, as the business unit owner, or even up to the executive board, depending on how large the enterprise software adoption is. And then how to really practically do it. Normally, it starts with a small team, a business unit that is a bit more open-minded, that maybe has a bit more liberty on choosing the kind of software and system they use. And then you would actually try to prove the case that, let's say an AI software or service actually brings value to the company. And then it actually gets adopted by maybe another BU until it actually reaches group IT. That's normally how it works. To be honest, my personal view on this is it's never really great if it's just a sort of like, let's patch it up kind of solution. You would work with, I don't know, like maybe some mini sites or websites or some workarounds. And the problem is, because of that, that's how you create this very fragmented IT system landscape in a company, because every team is sort of like, nobody wants to actually go through any formal approval process if possible, because it takes so much time. So people find workarounds, and that's how you end up having a large bunch of different languages, systems, and solutions.
So if, for example, I am someone in middle management at a large organization, and I was listening to Chris Rodmack's show, and I heard there about this very cool new library or this very cool new tool, and say, hey, we should be rolling this out at our company. How should I go about? Where should I start?
As I say, normally the most practical way is probably just to try it out in a way where it doesn't ring any alarms, or it doesn't, sort of like go against any policies, cybersecurity, but in a way still be able to test for it. I think the test case is super important. I think that's also where I think innovation labs or hubs really help to bridge and to create that kind of trust, and to support these POCs or pilots to make the case. I think it's also a little bit about luck and finding people in the organization that are a little bit more entrepreneurial, more open-minded, that actually help support a certain case. I think that's normally let's say, grassroots strategy or a route that most people go. I think another one is obviously top-down, where an executive board actually recognizes the value of a certain technology. And I think, there's lots of evidence we see in earnings calls and how often actually AI or artificial intelligence has been mentioned. So I think that also is another way where it's top-down driven, and an executive board is open-minded, or they deem AI as a crucial factor, technology for the future. And then normally it gets down to like maybe a group IT person. And normally there's another route where you go to the bigger players, companies like NVIDIA or Microsoft, and you try to like figure out, okay, is there a way where you can actually act within a specified or already like an existing contract framework that you already have with a supplier, which makes things so much more easy to implement than the other way.
So if I understood correctly, so one way to do it is that, for example, I go and reach out to my innovation unit and my organization and try to pitch them what I have in mind, and together with them, so work on some rollout plan or some like pilot program that we can then later go and present to a CIO, CTO, or other who is higher up in their hierarchy.
Exactly. That's way one. Or way two is obviously the more formal way of top down and going with like existing suppliers that are also very big in the market.
Yeah, I think, just to echo what Chris said, we have seen, different examples of how some organizations are deploying AI, for example. There are folks that go from top down. I know a few banks that are like head of AI, which is, really a new thing. And then there are also folks that, really trying to set up almost like a hub within the innovation labs, especially on the more, I guess, newer Gen AI application. So that's super helpful.
Max, I want to ask here, like, so from the side of like the startups, if like a startup wants to introduce to a large organization new technologies, so say for example this thing with CUDA, new startup does like a better CUDA and has some benefits and so on. How can this startup penetrate it? How can this startup, let's say, do some pilot and so with a large company?
So from my perspective, I think it really depends if the company has an existing vendor or not. Are you trying to solve a new problem? Are you trying to replace another vendor, for example? So if you're trying to replace a vendor, so if I take it in turn, like maybe I'll start off with, if you're trying to introduce something entirely new, I think to Chris's point, you do need to have some sort of a champion internally. Doesn't matter if it's them running the project, from grassroots perspective, or doesn't matter if they're coming from top down, trying to push certain application down. So that is what I've seen work. I think obviously you have a very key man risk here. More often than not, there are quite a lot of like big projects or big initiatives that have kicked off. Sometimes you even have investments around it, and in the end, the key person left, and then the project kind of just whizzle away, if you will, until the next person come in and take over. If you're trying to solve a problem where you already have an existing vendor doing somewhat similar, but not the best in what they're doing, so the best way that I've seen is really do a comparison. You almost go straight to the person that is currently implementing that system, and understanding I guess a little bit on the politics around it. Why are they incentivized to keep the current systems in place? If they're not, they're probably going to search out new systems to replace that. So to do that, then it's all about, I guess, proving the value, which I've in no doubt, a lot of the technology out there are very good. But it's just, being aware of the political situation of the individuals that are using the system or trying to push the system will be super helpful too. So it really depends on the system, whether or not it has existing players within the organization. At least from a startup perspective, I know, a lot of times it's all about, build and then sell as straightforward as we can. Unfortunately, with larger organization, there are microorganisms within it. So it's important to understand how all of that interact with each other. Now we talk a little bit about, I guess, how organizations could think about, the knowledge and bridging the gap of what's happening outside from a technology perspective and what's coming in. And I think one thing that, Eric Schmidt talked a little bit about is about knowledge systems and its limits. I find that quite interesting, right? I think he has a quote that say, there are folks that are creating things they don't understand. So I find that like, okay, that's alarming, sure. But, what is he trying to say? So with that, maybe I'll just play the clip and then we can, just do a quick comment.
The scientific revolution and the Enlightenment. And in your article, you argue that now these models are becoming so complicated and difficult to understand that we don't really know what's going on in them. I'll take a quote from Richard Feynman. He says, "What I cannot create, I do not understand." I saw this quote the other day. But now people are creating things they do not, that they can create, but they don't really understand what's inside of them. Is the nature of knowledge changing in a way? Are we going to have to start just taking the word for these models without them being able to explain it to us?
The analogy I would offer is to teenagers. If you have a teenager, you know they're human, but you can't quite figure out what they're thinking. But somehow we've managed in society to adapt to the presence of teenagers.
On this, what I find interesting is obviously the question itself, right? We're seeing a lot of different AI models. Are we at that point where we're creating things that we don't understand? Obviously, Eric Schmidt talked a little bit about how we could potentially see this play out, which I'll play the clip after. But before we get to that, I'd love to get your thoughts, Ron, on especially on the development side. We're building a lot of things very quickly. Love to understand a little bit on at what point do we get to a limit, at least based on a technical perspective?
Yes, this criticism has been around now for decades, pretty much. So back to deep learning, which is the set of algorithms that underpin what today we know as large language models, where we say that they are like black boxes. We say, hey, compared to other algorithms that were before that we're using in the community, there it was very clear through mathematics to really derive step by step what was happening. And now what we have, especially now with these LLMs, but in general also with all deep learning models, is a little bit of a black box where say like things comes in, other things come out. But this is just because we do not have fully the instruments yet, and that has been changing a lot. There has been like a lot of theoretical work that explain really how every model is functioning behind. So it's not anymore a full black box, or maybe some sort of like a gray box in a sense. It's true that compared to other methodologies, we do not have yet a full transparent explanation. It's not like a clear box, but this will change over time. We have to remember that this is relatively new technology, relatively new models and the algorithms behind, whereas something like let's say like a linear regression has existed for centuries. So of course it has had much more time to develop its theory and everything that explains how it works and different perspectives and so on. So on one side, yes, we do not fully understand it, but things are changing fast. And also in the end, is a question, do we need really to fully understand in order to assess that it's useful or to derive value from it? We do not really, that doesn't seem to be the case. We can also have something such as mechanisms or safe mechanisms that are after the output. So maybe we do not understand fully what's happening in the system, but once we get an output, we can assess, is this output relevant? Is, for example, what ChatGPT is saying real and so on? I get many comments from people who tell me, hey, I notice that ChatGPT is lying more and more and more. And this is like a way to verify it, right? So where I do not know where it's getting its knowledge from, I do not know how it is working, but when I get the output, I can confirm this is not what I want. So this can be another way also to circumvent these limitations of not fully understanding what's going on.
Chris, how about your thoughts? I find that quite interesting. But with a large corporate, most of the time they want to understand a lot of the stuff, or at least be able to articulate when it goes to a board meeting. So, Chris, what are your thoughts on this?
I don't want to answer this in a corporate context, but I think it's more a human context. No, it's like the fascination of what intelligence is. And honestly speaking, I don't think we understand our brains well enough to understand where exactly intelligence sits. And so, of course, what we are doing is basically mimicking the brain and the neural network. And this is basically the foundation of Gen AI or AI in general. And I think another human trait we have is to always be in control of things. And so we get very nervous when we don't understand fully what's going on. And I don't know, maybe this is also more towards Rod, a question that I have. But, there was this like big sensation a couple of years ago when DeepMind actually invented AlphaGo, and they made this famous game with, I think, the world champion of Go at the time, and they were playing 5 games. And I think at the end, AlphaGo actually won. And I don't remember the details, but essentially my understanding is there more possibilities of playing Go than maybe atoms or stars in the universe, something crazy. And of course, if we had to break it down and make it like controllable for us to understand, you would actually have to go through each and every possibility, and then the tree would branch out, and you would try to understand each and every variation of the game and every next step that you can do. But AlphaGo actually cuts through this by using heuristics and sort of like going into the upper tree or the lower tree and making educated guesses. And I think this is at least a bit of a way of how I explain it to myself, of how, larger models actually work. They make guesses and they have heuristics to work with. And so it's maybe a little bit like how a child would instinctively choose one or the other decision. And it's maybe not fully understandable as an adult, but it's still working and it's still an intelligent being, and we still trust the outcome of it. What do you think?
Indeed. So one of the characteristics of all these systems, it is that this ability of forecasting into the future, and to do this in parallel streams, where we as humans have limitations on how many things we can think at the same time, and we have to really focus on like tasks at hand, otherwise we can really do it. And also we cannot think, let's say, like 20 steps ahead, but maybe like 1 or 2, 3 maybe. And that's where our limits get. And what happens very often is that, for example, in this case of Go, yes, maybe there are millions of possibilities, but first, likely, historically, humans have not explored these millions of possibilities, but only a subset of that. And not only that, but also the system can play out all these historic options and see which one is the likeliest that the competitor, that the other person playing the game will try to make the move. And this is very similar to how LLMs work, how ChatGPT works, and so on, in that in the end it's about trying to, let's say, like forecast, predict the next word, the next combination of words, and so on. So where if I say this first word, then most likely will come the second one, and then based on the second one, the third one, and so on, and just based on one single word. So let's say from one single input, I can get a chain of words connected that can be so unlimited. And this also goes back to this topic of not understanding systems and so on. So why was it decided that this was the case? Well, in theory, it was decided through probability rules, so that was pretty much how it was. But what was the mechanism behind? We do not fully understand it. So always when people think about all this topic of transparent systems, so black boxes, white boxes, and so on, for me is like this philosophical reference of the Plato's cave. So where in the end we always see just a shadow of what's going on, and then based on the shadow we try to interpret things. We get very close to the reality, but we'll never be fully there.
From an intelligence perspective, yeah, I totally agree. I think this kind of just reflect on what's going on in the development, putting a lot of investment into, I guess, the overall understanding of intelligence. We may not have a very good understanding of it, but there might be some sort of outcome that we are trying to drive. Because it's beyond our understanding today, doesn't mean that it's beyond our understanding in the future. You need those investments to eventually to get there. We just have to kind of like trust the process.
And Max, staying on your question, so you were saying about transparency, and then, for example, presenting it to a decision maker and so on, that of course, so especially in large organizations, the context of large companies, where you say, hey, I come up with this new technology and I cannot fully explain how it works. It works, but I can't really tell you how. How can people navigate that on one side, let's say, to mitigate fears that say, hey, what if it goes wrong? What if, so we don't really know what's going on? But also at the same time, not being in a position to fully explain how the technology functions.
So the reason I guess I asked this question is, at least based on my experience in a lot of large corporates, a lot of the time you have to at least provide some sort of rationale or telling the story at the very least on why this technology makes sense. Sometimes it really depends a lot on the executive you're dealing with. Some of them are okay without the details. Some of them would like to have more details. And I am asking also from a context of regulated industry, especially when governments start probing into understanding more like what is going on within the systems. How are things gel together? Can you explain a little bit? The whole dynamic of explainable AI. The question is it actually that explainable? I do not know. So those are some of the questions that I have in my head. So far, to route around this is, sometimes you can class it as an innovation project. Sometimes you can class it, almost as I would say, a means to an end, right? As long as a lot of the outcome is driven through certain technology, we don't necessarily have to understand everything. And the reason, we've seen some of that, especially from a software perspective, on the monolithic software, while we understand what goes in, what comes out, but not a lot of people understand how it works from a process perspective. Hence, every time you do some upgrade, it kind of just breaks. So there's also a little bit of that in play. It's all about, I guess, driving to a certain outcome and making sure that we're able to do that over time as well. At least that's my view on this topic. Cool. And if I were to shift gears a little bit, I think Eric also talked a little bit about Mistral's new model. And the reason why this is interesting is because he trying to outline the capital costs for AI is so immense that some of the leaders are pulling away from, I guess, the other smaller players. I don't know if this is true, but I'd love to hear your thoughts. But before I hear your thoughts, let's just jump straight to the video.
Well, the question is roughly the following. There's a company called Mistral in France. They've done a really good job. And I'm obviously an investor. They have produced their second version. Their third model is likely to be closed because it's so expensive. They need revenue and they can't give their model away. So this open source versus closed source debate in our industry is huge. And my entire career was based on people being willing to share software in open source. Everything about me is open source. Much of Google's underpinnings were open source. Everything I've done technically. And yet it may be that the capital costs, which are so immense, fundamentally changes how software is built.
Cool. So that's, something that I guess I've been thinking about, right? We're obviously seeing the divergence in how large corporates are trying to deal with the different models. So on one side, you have Meta, obviously open source Llama out to the world. And then there's also folks like, I guess, some parts of OpenAI, they're trying to be a little bit close to us. I think, just from a capital intensive perspective, from, I guess, the pros and cons, if you're a, founder, how should you be thinking about this? Rod, maybe I'll go to you first.
Before that, so what is fantastic here is that very often, not only in our show, but also in general in media and the society, we discuss about lack of innovation in Europe, or that so Europe is being left behind in terms of AI and other technologies. But here we have an example of so Eric Schmidt praising. Of course, it's a little bit like this meme of proud investor because it's one of his portfolio companies. But so he's praising an AI startup based in Paris, France, where also France, not necessarily we might think, oh, this is like the cradle of innovation. And we can see that it's still possible. It's still possible to, outside of the US, also Silicon Valley, to build meaningful and impactful companies. But to your point of, so here, these open source models and closed source and so on, this is what will define, like, let's say, a little bit the race of AI. So where we have, let's say, two schools, two philosophies. On one side, we have OpenAI, so that everything here you have to pay and it is closed. You will have no idea how in practice really GPT-4o, GPT-4 and so on work. Sure, OpenAI does a lot of research, academic publications and so on, where they provide some explanations of how it is, but we do not on one side have access to the code, how it really looks, and more importantly, we do not have access to the data set that they are using to train all these models. So even if on their academic publication they say, we built this model so and so and so, the most important part, which is the data, we never have access to that, and as a result, we do not really know how it was built. And then the second school of thought is, for example, like Mistral and also Meta and so on. They're saying, on one side, we need trust in AI. One way to establish this is by being transparent and then offering pretty much everything here available. So where you have access to the weights of the models. So you have access to really how the model is built. You also have a lot of information on how the model was built, what like the data was behind and so on. And also not only that, but the access to the model is free. You don't have to pay for it. anyone can just go to the internet, download it, and start using that. But then, so to his point is on these massive capital expenditures that are required in order to develop this. We need a lot of infrastructure, servers. We need also so much overhead in terms of highly qualified experts. We need to spend a lot of energy into doing all this computation and so on. So we're talking about really spending millions in order to just get one of these models ready. And the question will be always, where will this come from? Potentially, it might be that this might be an undertaking that is, let's say, like a societal one, that we say we as a society need to foster this for the benefit of humanity. So it becomes something where governments might be, let's say, funding all these advancements. Or it can be just this idea, for example, in the case of Meta, where they're seeing this as a way to protect themselves from new entrants. So saying, if the future is AI and others are doing it, and if all these eyeballs are spending time in ChatGPT instead of chatting on Facebook, then we need to do something. And to that point, just so this week there was this announcement that now Meta, through its multiple platforms, they have 400 million users that are using their chatbots. So here Meta has already created a relevant competitor to ChatGPT that we're not really aware of, because it's not really like a product. It's not really, let's say, like a specific brand. It's just something that's embedded in their multiple systems, in Instagram, in Facebook, and so on. So for them, it's already paying out the fact that they're spending so much money on all these open source models, with the additional benefit that they are also planting the seeds for new OpenAI competitors, such that OpenAI never gets too strong, because they will always be competing with others that are being powered by technologies that Meta provided.
Yeah, I think the seeding new competitors is quite interesting to me. I think, Chris, from your perspective, especially on adoption and competitive landscape perspective, I'd love to hear a little bit about thoughts. Have you seen, I guess, a difference between open source, closed source in different software industry? Just to hear a little bit about thoughts, because of the capital costs and support they're going into one company. My understanding is it may not be always the best software just because you put more money into it. At least that's what I like to understand. I like to believe. And therefore, just because you put a lot of money in there and turn it into the best software in the world, doing it closed source, may not actually, in this point, is more about supporting the creation of the software. But, from an adoption perspective, does it change the way you think about it?
That the logic is not so sound that Eric Schmidt actually used. Essentially, he's saying, listen, my entire career I've been working on free stuff, and we can't do it this time around because it's so expensive to build AI. And I want to separate it because I think there's something around business models. And also Google can do all these things for free, like, for example, Gmail, etc., Google Maps that we use day to day for free, is because they found a business model and someone else to pay for it. And those are the advertisers, right? And the other thought I had was open source versus closed source is basically what Rod described. It's whether or not you can look into the code or you can't, and can you collaborate and fork or duplicate the software or the code and do something with it. And I think we do have other companies where you have an open source approach. For example, Linux is one. They provide their software, but they found other ways and means to monetize it. So I think this is the way I would actually also apply here in this case around AI, which is, okay, you can or cannot make a code available to others. And this is one part of your strategy, but still you have to figure out the other part, which is how do you make money and cover your costs. And so for me, this is a bit of a nuanced sort of distraction or sidestep, to be very honest. And I think overall the question is still standing, which is how do AI startups or companies make money? And usually the answer is with some kind of service on top of it, right? So maybe you don't pay for the software code per se, but you pay for having this beautiful interface called chatbot, or you pay for maybe even consulting services that NVIDIA helps to build up something for your enterprise that has something to do with cloud and AI. That's normally how to think about it. So one way is to think about the investment costs. And I think for startups, it's really coming from VC pocket money. And these days, obviously, very deep pockets required in order to build some of these models. But then again, there's this, like, let's say, front end where you need to think about your business model. And I think that's a challenge for any new starting company in technology or elsewhere.
Great. I think given that you talk a little bit about the different services, which I think, Eric also touched a little bit about, he talked about three things. The combination of context window, agents, and text to action, which is really things that you can build on top of those models and those investments in order to get to some of the end outcome that you want to. And with that, I will just play a quick clip about him talking about that. And I'd love to get both your thoughts around that.
I think largely because the context window allows you to solve the problem of recency. The current models take a year to train, roughly 18 months, 6 months of preparation, 6 months of training, 6 months of fine tuning. So they're always out of date. Context window, you can feed what happened. Like, you can ask it questions about the Hamas-Israel war, right, in a context. That's very powerful. It becomes current like Google. In the case of agents, I'll give you an example. I set up a foundation, which is funding a nonprofit. It starts, I don't know if there's chemists in the room. I don't really understand chemistry. There's a tool called ChemCrow, C-R-O-W, which was an LLM-based system that learned chemistry. And what they do is they run it to generate chemistry hypotheses about proteins. Then they have a lab which runs the tests overnight, and then it learns. That's a huge accelerant in chemistry, material science, and so forth. So that's an agent model. And I think the text to action can be understood by just having a lot of cheap programmers, right?
For me, what's interesting about this is he was trying to bring some of the LLM stuff that we've been talking about to life, utilizing things like context window, bringing things current, agent by having something running models for you day and night, so without you doing yourself. And next is really us turning whatever language that we want to tell something into any sort of code, and then it will take action in the digital context. And we have been spending some time talking about different use cases, and I just wanted to hear from both of you, by combining all three of that, what are some of the, I guess, interesting possible use cases that we could be thinking, and also what are some of the, I would say, things that corporate needs to consider when it comes to adopting AI, when it takes all three things into account.
I want to provide a bit of context first for those in the audience who do not know what are agents. And agents is a full new, almost discipline that is happening in generative AI, with the idea that all these large language models can be seen as, let's say, like grunt workers. Or I can say, hey, what if, like, I have multiple GPT models or any other model, Mistral and so on, that have assigned tasks, and I can coordinate them between them. So normally when we think about, let's say, preparing a spreadsheet, let's say, with the list of largest companies in the world by revenue or something like this. This means that we need to carry out multiple tasks. We need to figure out on the internet who are the largest companies in the world. And then we need to find out, okay, where can I find information about the revenue and so on. So we need to plug in multiple sources. We also need on the spreadsheet to do some formatting and so on, right? So here are multiple tasks associated. And the other with agencies, what if we could delegate these tasks, the individual ones, the research, the formatting of the spreadsheet, the combining data source and so on, and each task is given to a different AI model, and then another model is coordinated together, and in the end present the final product. So this is what is seen as, let's say, the next frontier in AI, and start to seeing this as not, let's say, so smart humans who are inside a computer, but rather as capable single task like grunt workers that are doing things in parallel and combining this to do full workflows. And so here what he's saying is, for example, one example here with so here chemistry and so on, so where especially in life sciences, you need to carry out so many trials, you need to be exploring so many options. We're discussing with Chris about, for example, here Go, where there are so many combinations that are possible. So what if you can have, let's say, a full team of, let's say, virtual researchers who are testing combination of compounds of things and seeing what works, and then in the end come to you the next day with the combination of a compound that had the best results. And what we do not see is that, let's say, during at night, it was not, let's say, one researcher that was doing this, but it was let's say, quote unquote, like a team of millions of models that were trying different combinations in parallel.
I would actually love to see a world, and this is maybe taking it a bit further, but where we wouldn't be doing the research manually, or the Excel file manually, or the PowerPoint or whatever file we're trying to modify, and not having this research skill, let's say, but rather that everyone, and hopefully also already in school as a mandatory class, gets to learn about programming. So I wouldn't necessarily agree with this whole, oh, we have a couple of cheap programmers. I actually believe that programming and understanding computers and sort of building these kind of workflows that you're describing, Rod, should be an essential, class like math or language or whatever it is, for everyone to be able to build it. Because, going back to our previous conversation around, companies, larger organizations, and there are all these like challenges and obstacles of adopting new technologies, etc. Yes, of course. I mean, people, the work they don't know how to use AI. They don't know how to plug workflows together. And even using something like a Zapier or Bourdain or whatever it is already really, really difficult, because they don't maybe understand the logic or underlying infrastructure around it. So I think we would be living in a more efficient, better, less menial work kind of world if all of us would be able and capable of understanding human to computer systems, and also being able to plug in workflows together.
I think I would love to live in that world one day, Chris, so I don't have to do all these menial tasks. But with that, thank you so much, everyone, for tuning in this week. We had a very engaging conversation, and we hope you will tune in again next week, and we'll break down more AI news. Thank you so much again for joining the Chris Rosmack Show this week. We'll see you next week. Please like, subscribe, and share with whomever you think would be interested in this. Thank you.
And thank you so much for all who are leaving their comments, who are giving us feedback, and who are really supporting us in this journey of exploring AI. It always made me very happy to see their comments.
Awesome.